Well, hello there, boys and girls. Welcome back. It is April 14th, 2020, and I am hoping that you guys had a lovely, long, relaxing, restful spring break and back to school. And I would love to be able to say I'm so glad to see you again, but alas, we are still here at home with the coronavirus in April 2020. Thoughts and prayers go out to all of you guys, all of the ones who have been affected, with loved ones who have been affected by this terrible disease. But I have faith that the doctors and the scientists are working very hard to come up with a vaccine, and we will hopefully get back to some normalcy here in the very near future. So we are moving on to the last unit in the geometry curriculum on probability. This is a little bit of a tough unit, guys. One reason why it's tough is because we're used to calculating numbers and setting up equations and formulas and calculating angles and side lengths and solving for unknown variables, but that's just not going to be the case in the probability unit. A lot of this unit is logic and common sense, and you have to think about each individual problem separately. So sometimes there's not necessarily a clear cookie cutter recipe for solving each problem. Some of these you just have to think about it and use the fundamentals and the concepts that we're going to learn about in this unit to be able to solve the problem. So make sure that you guys are completing your homework every night and studying this stuff, and I will be perhaps putting out some more practice problems for you guys over the course of this 2-week unit, especially if you request it, if you think you might need some extra practice, because the best way to do this unit is just to do lots and lots of problems so you have a good understanding of doing that. All right, so in this packet here, we've got a 24-page packet. This packet has everything that you need in this entire unit. The quiz reviews, the test reviews, the homework, everything is included in this packet. So I will take up this huge packet the day of the test for a grade. So let's go ahead and jump into day one. In day one, we've got some probability, some Venn diagrams, and some basic probability. So the front part of this lesson will be a little bit tricky, and the back part of this lesson will be super, super easy. So let's go ahead and jump into this and start out with some vocabulary. And so we have day one. We have sets, set notation, Venn diagrams, experimental versus theoretical. All right, so first off, we have a set. What is a set? A set, okay, a set is a collection of objects. It's a collection of things. It could be numbers, it could be words, it could be emojis, it could be a collection of Clemson football trophies, that kind of thing. The items in a set are called the elements. What do you call dihydrogen oxide? For those of you guys that like chemistry, dihydrogen oxide. That is dihydrogen oxide. Water. Okay, that's a joke. A universal set is a set. I'm going to do this in two different little rows here. A set from which all others are drawn. A universal set is a set from which all others are drawn. So it's like the overall set. It's including everything in the universe. Okay. Don't start this on me already. It was like a Monday, but of course it is Tuesday. Come on. All right, an empty set is a set with no elements. There ain't nothing in there. I don't think my webcam, I don't think there's anything in my webcam brain. There's nothing in there. Let me see if I can. Sometimes it is not perfectly. Hey, there we go. Sorry about that, guys. Sometimes if it's not perfectly perpendicular, with the camera. All right, so an empty set is a set with no elements, and that is notated by a 0 with this big line through it. That is called a secant, right? The line that goes all the way through the circle. All right, it says we often use Venn diagrams. You guys have seen these before, I hope. We often use Venn diagrams to display sets. All right, it says 3 common operations are performed on sets. So we got the union, the intersection, and the complementary. Complementation, the complement, several different ways you can say that. And you guys have to get real familiar with these 3 different words and the 3 different symbols that I'm about to teach you here. All right, first up to bat, we have the union. The union is the operation that combines, circle that word for me, it combines 2 sets. The union of sets A and B is the set that consists of all of the elements of A in addition to all of the elements of B. Okay, so let's stop for a second. What does the word union actually mean? Union means to come together, right? If I fuse 2 things together, I've had double spinal fusion back surgery. After all the years of playing sports, they fused 2 of my lower vertebrae together. So that becomes a union. 2 people get married, okay? They come together, get married, and perhaps they have children, and you got parent A and parent B come together, they have children, and so they combine, they form a union, okay? Our states were a union, are a union, okay? So a union means give me everything, okay? Give me all of dad, give me all of mom, give me all of the children, give me all of A, all of B, all of the overlap, give it all to me, okay? The symbol for union is a U. Wow. U for union. Imagine that. That's pretty cool. The symbol for union is U, and we write this as A union B. And it's really not a normal U. It's really kind of an overgrown U. Like my daughter in 5th grade, she's the tallest girl in the school. So it's a little bit bigger than the other. Should be a little bit bigger than the other letters. All right, so that's the union. Give it all to me, everything. All right, second, we have the intersection. The intersection of sets A and B is the set containing all the elements that are common to both sets and is denoted by a upside down U. But here's the word, guys. This is the most critical word maybe of this whole lesson for Venn diagrams: overlap. Okay, the intersection, we got union, the intersection, I want you to think overlap. Okay, the intersection on the streets, or geometrically, if I've got 2 circles that combine, you'll see down there at the bottom here, 2 circles that overlap. The intersection is the middle, the overlap. So you've got parent A and parent B, the children or the overlap, if you want to think about it that way. Okay. All right, so the complement, this is the third one. The complement or complementation is a set of A. This complement of set A is the set of all elements in U and not in A. Okay, not in A. We can write the complement as, there's 3 different ways that you might see this. There's really only one way that we're going to see it. You might see this guy, A with a little subscript C, kind of like the little copyright symbol. And then you're going to see A tick, like A prime from our coordinate geometry unit. Or you might see squiggly A. Okay, definitely you're not going to see that A with the subscript, or excuse me, superscript C. You're not going to see that. What we're going to see most of the time is this little A tick, A prime. Okay, so that denotes complementation. And here's the word I want you guys to think of: opposite. Okay, opposite. So when you see A prime, I'm thinking everything not in set A. Okay. All right, so here we go, guys. Venn diagrams. Now listen to me very carefully. This might be one of the trickiest things we do in this entire 2-week unit. Okay, these guys are pretty tough. So I really need you guys to pay attention, take some good notes, go back and look at your notes when you're working through the homework, and make sure you work a lot of these problems so you can get this stuff down. You will never, let me just go ahead and say, everything that we're about to do here with these Venn diagrams, okay, I always like to talk about the real world application. I can stop there for just a second. Again, what is the real world application for probability? Well, it's all over the place. This is how Six Flags, amusement parks, casinos, the fair, when you go to the fair, you got that annoying guy out there blowing that horn, hey, come play my basket game that nobody ever wins. You got this huge teddy bear that only 3 people in the history of the universe have ever won because it's impossible to throw that huge softball in a basket that's only 2 millimeters deep, right? And so I can guarantee you that these fairs are using probability and statistics to figure out, okay, so if I have 100 people come up and throw this ball in the basket, only 15 people are able to do it. Okay, that means we're going to make X amount of dollars per 100 people. That means that we can afford to give away X amount of dollars in prizes. We can afford to give away this huge teddy bear that might cost us $20, because only 3 people are going to win it. That's going to cost us $60. And if we charge $2 per game out of 100 people, that's $200. We just profited $140 out of every 100 people or whatever. I'm just making up numbers here. But casinos, the same way, everything in the casinos, everything is based on probability and statistics. In fact, I don't know if you guys knew this, but I've always found casinos fascinating. But if you go to a casino and you go to the blackjack table, right? You're dealt 2 cards, the dealer's dealt 2 cards, you want to hit or stay, you're trying to get as close to 21 without going over. If you turn into a robot, and there are actually books out there that will teach you how to become a professional blackjack player to make all the decisions. When I'm showing a jack, when I have 13 and the dealer's showing a jack, do I hit or stay? It's amazing. The percentages for the house, the casino, is only about 51 to 49%. The casino is only going to win about 51% of the time if you make all the correct good decisions. So theoretically, you could sit at a blackjack table if you knew all the rules and all the different scenarios. You could play almost forever and basically just break even. You would lose a little bit of money over the long run, but what people have to understand is that when in a casino, when you've got tens of millions of dollars changing hands, the casino is profiting millions of dollars every day off of just 1%. Of course, the other games, the house is winning 20% of the time, or they're winning 80% of the time or 70% of the time. But anyway, that's just a kind of a little background. Why is probability important? But probability is used in sports. It's used in the weather, right? What are the chances going to rain tomorrow? Okay, so I love this unit. I love probability. Okay, but here, now, the reason I prefaced you with that is because this right here, guys, you will never do in a million years in your job. I'm just going to go ahead and throw that out there. You will never do this. You will never sit down in your job and try to figure out what is K prime intersection L prime from a Venn diagram. This right here, guys, is a wonderful skill because this is teaching you logic. Okay, these are logic skills, okay, that you're building and enhancing. Okay, so don't turn up your nose at this stuff. I love it. I think it's very interesting. All right, here we go. Solve the problems using the Venn diagrams. Now, I'm going to tell you guys right now, if you don't do the way that I show you to do it, it's going to be very, very confusing. I'm going to go the route of using colored pens or pencils or markers or whatever. If you don't feel like getting out anything colored, if you don't want to highlight this stuff, I would strongly suggest that you use a pencil. Please don't do this with pen because I'm going to mark all over this stuff. In fact, I printed out several copies of this because normally when I do these problems on the board in my classroom, I'm erasing all this stuff. Okay, so don't do this in pen or you're going to go insane in the next 20 minutes, right? I'll have to put you in a straitjacket, okay? So if you want to, use a light pencil, and every time I circle something, if you don't want to use colors, put a little triangle or use a little square so you can see the difference between the triangles and the squares. If you're really bored, you can do little dodecahedrons or whatever you want to do, okay? But you need to follow the way I'm doing this. Okay, the first one up to bat is we have K prime, and we have this upside down U, and then we have L prime. Okay, so let's stop for a minute. What does the upside down U mean? Okay, upside down U, that's our intersection. And what's the word for intersection? That's the overlap. And then K prime, right, means the opposite. So I want the overlap between the opposite of K and the opposite of L. Okay, now in this unit probability, we're going to look at playing cards. Okay, I love cards. I love playing cards. I play cards my whole life. And if you guys have never played cards, number one, that's very sad. Number two, you need to sit down with your friends, your family. This is a great time to do it while we're all at home. Play cards with your family. If nobody in your family knows how to play cards, Google it, YouTube it. Okay, YouTube card games. Okay, it's a wonderful pastime. spend some time with your families and forget about school and get off your technology devices for a little while. Okay, so anyway, I'm going to use a card to cover up what we don't need. Okay, and I'm also going to use different colored pens. So the first thing I'm going to look at is I'm not going to pay attention to anything right now except the opposite of K. I don't want K. All right, so we've got two circles and we got the overlap. How cute is that? We got circle K. That's cute. Okay, so I don't want K. So watch this. I'm going to put a card. I'm going to cover up circle K. I want the opposite of circle K. All right, so I'm going to circle everything that's not in K. So that's 5, 11, 1. And don't forget about these guys outside. Okay, we got 3 numbers here that aren't in either circle. Now, eventually, in the later problems, we're going to have Venn diagrams. We've got McDonald's, Chick-fil-A, Burger King, baseball, basketball, football. But just for now, we just need to get the concepts down. These are just random numbers. We don't know what they mean. Okay, so that's everything that's not in K. All right, the next thing is I want not L. Okay, so I'm going to take my card and I'm going to cover up L. I don't want anything inside of circle L. I'm going to pick another color. Why not just pick this beautiful orange color? I want everything that's not an L. So I'm going to circle in orange everything that's not an L. Okay. All right. Now, once again, if you're not using colors, those need to be squares and triangles, or circles and triangles, or icosahedrons, or whatever you want to do. Okay. Now, we want the upside down U. We want the intersection. We want the overlap of not K and not L. So what that means is the overlap is where I circle them twice. Where do I have the purple and the orange circled? I've circled them twice here, here, and here. Okay, 6, 10, and 18. So that is my answer. 6, 10, and 18. It doesn't matter the order. Okay, it doesn't have to be numerical order. We just need everything that is the overlap of not K and not L. Now, if that's confusing, again, at any time, guys, as always, pause the video and go back and rewatch it if you need me to explain something. If you need me to explain something slower, then take the YouTube clip and go 25% of the speed. Just kidding. All right, so let's keep going. All right, so the next one, now here, again, this is why I say if you're doing this in pen, you're going to be messed up because you can't erase this. Okay, so if you're doing this in pencil, if you did the squares and triangles, whatever, you're going to have to erase all this. Or if you want to print out some extra copies, if you want to pause the video and print out some extra copies so you can start from scratch, or if you just want to go over here on a scratch sheet of paper and just draw these two circles and you just recreate this little diagram. It won't take you but 10, 15 seconds to recreate this little diagram on a separate sheet of paper. I am going to start over with a fresh new sheet. Okay, so the next one we have L minus not K. Okay, so where is L? Okay, I want everything. Obviously, I don't need cards for this, but I'm just going to keep up with that concept here. So give me everything in L. Circle L. Okay, got that. Every number in circle L. Okay, and then I want the not K. Then I want my camera to focus. Okay. All right, I want not K. So I'm going to cover up everything in circle K. All right, I want everything that's not in K. So I'm going to circle that. That is everything that is not in circle K. All right, now what we're doing here is a lot of the times we're just using the union or the intersection. We're just using these symbols, but now we actually have a mathematical operation. L minus K prime. This is just like 4 minus 2. I'm just subtracting. So from L, okay, I'm only looking at L. From L, I'm going to take away the not K's. Okay, purple was the L. Orange was my not K's, but I'm only subtracting this from everything inside of circle L. So I'm going to take away the not K's, which were orange. Okay, I don't want the orange because I am subtracting. Okay, that is going to leave me with the 3 numbers in the middle here. It's going to leave me with 3, 4, 14. Okay, so I'll give you a second just to kind of digest that. We circled everything in L. We circled everything in L was purple. Everything in not K was orange. So from the purples, from 4, I'm going to subtract 2. From the purples, I'm going to subtract the oranges. Okay. From the grapes, I'm going to take away the oranges. I'm left with just these 3 grapes. Okay. Now, the next one, I want you guys to try it on your own. So I want you guys to pause the video and see what you can come up with for L minus K. Okay, so hopefully you guys were able to do that one. Let's walk through that one. Again, I'm going to grab a fresh sheet of paper. Let's start over here. L minus K. All right, so I want everything in circle L. Okay, that's all these purple numbers. All right, and then I want everything that's in circle K. Okay, I'm telling you guys, please, 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 I wish y'all could see my face right now. I'm begging you to circle these some way, somehow, exactly like I'm doing. I know some of you guys are going to try to do this in your head. I can feel it in my bones. Please, please don't do that. This stuff is just too tricky to try to do in your head. Wait a minute. Now, wait, was it these 3? No, just don't do that. Circle it, triangles, whatever you need to do. Color. Okay, so let's go back to our problem. L minus K. Okay, so from the purples, I'm only looking at L. I'm only subtracting from L. From the L's, from the purples, I'm going to take away the K's. I don't want the oranges. Okay, and I'm going to be left with those 3 grapes, which is 1, 5, 11. Okay. All right. I don't need a new sheet of paper for K. That's the easiest thing you've ever done in your life. So literally just give me every number that's in a circle K, which is 3, 4, 14, 17, 16, and 20. Okay, that's easy. Now this is not on our packet, but I want to do this one anyway. I want to go back up to let me get a fresh sheet of paper. I want to go back up to this guy. We haven't done one with a union yet. Okay, that's the intersection. What if I did this one, the same exact thing, K prime, but now I have the union L prime. Let's do this one together. Or again, if you want to pause the video and try that one on your own, see what you come up with. Okay, so I want the union of not K and not L. Okay, union means give me everything. So that means when you see the union, every time you circle a number, every time you put a triangle or a box around that number, every time you do that, you are going to include that. I want all of dad, all of mom, all the children, the overlap, give it all to me. Okay, so we want not K. Okay, I don't want anything in K. All right. All right, and then I want not L. So I don't want anything in L. Okay, and then I want the union. That means anytime that I circled something, then I'm going to put that down, right? Okay, so this was not K. That was the purple. This was the not L. That's the orange. So every time I've circled something in purple or orange, I've got to write that down. So it's basically every number is set before 3 and 14. So that's going to be 20, 16, 17, 6, 10, 18, 5, 11, and 1. Again, order doesn't matter. We just need to make sure we're capturing all the ones in the set. Okay, how you guys feel? Hopefully you're okay with this. You're getting this. I know it's can be pretty tricky. All right, so let's keep going. We got another example down here. All right, so again, at any time, guys, if you want to pause the video, work every one on your own. Okay, you don't have to watch me go through it. See what you can do on your own. All right, I want the intersection. I want the upside down U of G and H. What does intersection mean? What does the upside down U mean? That means the overlap. Okay, so give me everything in G. Now this one, again, you guys, maybe you don't, something like this, maybe you don't need to cover up stuff because you can obviously just look at it. All right, so that's everything in G, and then give me everything in H. Okay, and then the upside down U means I want the overlap. So obviously, you guys could have just looked at the 2 circles and said, okay, these 3 guys in the middle are the overlap, and that's fine, but I still want to stick to my concept of circling things and blocking stuff out that you don't need. I'm telling you guys right now, if you cover up stuff that you don't need, it's going to be so much easier for you. G, H, and Z. Okay, that's the three guys in the middle. All right, again, pause the video if you need to. I want the intersection of not G and not H. Okay. Clean sheet of paper. Okay, so give me not G. I don't want anything in G. That's the complement of G. Okay, so give me all of these guys. Okay, give me all of not H. Okay, so let's cover up H. Do this in a different color. Okay, and then I want the intersection of those guys. So the intersection, what's the word for intersection? Overlap. So where do I have orange and purple at the same time? It's these three guys, C, E, and A. Okay, so hopefully you got that right if you pause the video. Again, try the next one on your own if you like. Another clean sheet of paper. Yeah, I did. I printed out like 10 copies of this so that it wouldn't get messy. But again, you can just erase with your pencil if you draw lightly for each different problem here. Okay, where are we? We're on this one here. We want not H minus not G. So we want an operation here. All right, so give me not H. I don't want anything in H. Okay, nothing in H. Okay, that's those guys. And then I want not G. So take away everything that's in G. I mean, excuse me, I want everything that's not in G. Okay, but now I'm subtracting. Okay, I'm taking everything that's not in H. That was everything that's in purple. So I'm only looking at the purple guys. From those guys, I'm going to take away the not G's. That means from the purple, I'm taking away the oranges. So I'm only looking at those guys, but I'm taking away those three oranges, and I'm left with those three grapes. I don't care about these guys because I'm subtracting it from purple. I'm subtracting it from not H. So that's going to leave me with these three guys, which is N, Q, and X. Okay, a little tricky again. And the last one, yes sir, there's your challenging problem for the day. I would let this be a Mr. and Niece challenging problem. Not that hard, but it is the hardest one of all of them. So again, pause the video if you'd like, see what you can come up with. Okay, let's see what we got right here. Right here. Okay, so I'm going to do G minus H. All of that is in parentheses, though. That's the difference between this one and the one above it. In parentheses, I have this little tick outside. So we use order of operation, right? PEMDAS just like anything else, okay? I'm going to do the stuff inside the parentheses, and then I'm going to do the exponent, which in this case is our little tick or the opposite. So I'm going to do G minus H, and then I want that opposite of that, okay? All right, so let's do G minus H. Okay, so G, I want all of G. Okay, give me everything in G. Okay, I'll give me everything in H. Okay. All right, now I want to do G. Forget about this little tick. Just forget about that. We'll do that at the end. Then I want to do G minus H. Okay, G minus H. I want to do purple minus the orange. Okay, so from the purples, only from the purples, I'm taking away the oranges. Okay, so I'm taking away those three guys, and I would be left with the same thing that we just got above. Okay, I would be left with, I'm not going to write this over here. I would be left with N, X, and Q. Okay, everybody follow that? All of purple minus all of orange leaves me with these three purples. But I want the opposite of that. I want everything except those three guys. So I'll do this in green. So now I want the opposite of N, X, and Q. And what is that? That's literally every single other letter that's not in X and Q. Okay. There we go. Okay, so I want everything other than the three X's. So that's literally every other letter. So we've got C, E, A, what is that? H, Z, G, W, R, B, P. Okay, every letter except the ones that I crossed out. Again, this is just logic and reasoning. Okay, pretty tricky stuff, guys. All right, the rest of this lesson is super, super easy, but yeah, make sure you guys have that down. Rewatch the video if you need to. Okay, let's move on to some really, really super easy stuff. Super easy stuff. Okay, here we go. Basic probability. All right, you guys already know most of this anyway. You really don't even need me for most of this. All right, so it says you can write the probability of an event as a ratio, a decimal, or a percent. Three different ways. So if I flip a coin, the chances of it landing on tails is a ratio. That will be 1 out of 2. 1 out of 2 times as a decimal, 0.5, or as a percent, 50% of the time it lands on tails. Okay, this guy right here, keep your eye on this. This will be on the quiz. Okay, so make sure you kind of have a good understanding of this. Here's just kind of a scale. At 0%, it cannot occur. If there's a 0% chance of something happening, that means it is impossible for it to occur. So that would be like saying something like next year, the chances of South Carolina beating Clemson in football is 0%. Okay, it's impossible. It's literally physically, universally impossible for that to happen next year. In fact, it might be impossible for them to do it in the next 10 years. I'm not really sure. Maybe that's like 0.1% or something. All right, so if you're in between 0 and 50%, it means that probably not going to happen. 50% says it may or may not occur evenly, obviously. Between 0.5 and 1 is probably going to occur. And that's what majority means, right? 50.01%, that's the majority. That means more than 50%, more than half is the majority, less than half is the minority, okay? If it's a 1, probability is 1, that means 100%, that means it's certain to happen, okay? It says you can find the probabilities by using results of experiment or by reasoning mathematically. Okay, so we got two different types of probability in this lesson. We got experimental probability and theoretical probability. Okay, and it's easy. It's exactly what it sounds like it would be. Experimental probability, let me try that again. Experimental probability is the result of an experiment or simulation after a large number of times or a large number of trials. Okay, so what I want you guys to write in your notes for this guy right here, I want you to write, this is what actually happened when we ran an experiment. We flipped a coin 10 times. We would expect 5 of them to be tails and 5 of them to be heads, but that's not necessarily going to be the case. I could flip a coin 10 times and it can land on tails 10 times in a row. It's not very likely that would happen, but it's very possible. Okay, so experimental is what actually happened. Maybe we flipped a coin and it landed on tails four times out of 10 and landed on heads 6 times out of 10. Okay, theoretical probability is what is expected to happen based on the possible outcomes, assuming equally likely events. Okay, so this is what is supposed to happen. I flip a coin, it's supposed to land on tails 5 out of 10 times or 500 out of 1,000 times. Okay. Experimental probability, how do we calculate this? It's just simply the number of times the event occurs over the total number of trials, 3 out of 10 for flipping a coin. Theoretical probability is the number of favorable outcomes over the number of possible outcomes. And when we write this little probability, we use these little parentheses. What's the probability of drawing a yellow marble out of a bag? P parentheses yellow, or P parentheses tails for flipping a coin. Okay. Now, let's say that we flipped a coin 100 times and it landed on tails 42 times out of 100. That would be the experimental probability, 42%. The theoretical probability will always be 50%. So I want to introduce, this is not in our notes, it really should be in our notes. I want to introduce this to you guys. Law of large numbers. Write that down for me. What do you think that means? The law of large numbers. We flipped a coin 100 times, it landed on tails 42 times out of 100. Well, that's not really close to 50%. That's a good bit off, okay? But what do you think would happen if I flipped it 1,000 times? Do you still think it'd be 42%? What if I flipped it 1,000,000 times? So the law of large numbers essentially says that as you run the experiment more and more times, as you do more and more trials, the experimental probability should do what? It should approach the theoretical probability. I flip a coin 10 times and it lands on tails 3 out of 10, 30%. That's nowhere close to 50%. I do it 100 times and now it's 42%. I do it 1,000 times and now it's 48%. I do it 100,000 times and now it's 49.1%. I do it 1,000,000,000 times and now it's 49.999%. Okay, and that's what the law of large numbers says. Over time, the experimental will approach the theoretical probability. Okay, so let's go through some simple basic probability that you guys could do without me. Cameron has 8 blue marbles, 5 red marbles, 7 green marbles in a bag, and we're going to do a whole bunch of these marbles in a bag problems to get used to this. If he picks one out at random, what is the probability that he gets a blue marble? Now, does that say experimental or theoretical? Doesn't say, right? Okay, so if it says what is the probability, what does that mean? It is insinuating that it's asking for the theoretical probability. What should happen? Okay, and this is just, again, the number of favorable outcomes over the number of possible outcomes. Okay, what is the probability that he gets a blue marble? Okay, so this is going to be our probability P parentheses blue, and that's going to be equal to how many 8 blue marbles? There's 8 blue marbles out of the total number of possibilities out of what? The total is 8 plus 5, 13 plus 7 is 20. So the probability will be 8 out of 20. Listen to me very carefully. Listen to me very carefully. Do not leave your fractions unsimplified. Guys, it doesn't work like that in the real world. You always simplify. When you tell me the probability is 8 out of 20, I don't immediately, within a couple of milliseconds, I don't immediately know exactly what that means. But if I simplify that, divide by 4, if I simplify that to 2 out of 5, okay, 2 out of 5, then I can do that math a little bit more quickly in my head, right? 5 times, what do I have to multiply 5 by to get to 100? I got to multiply 5 by 20 to get to 100. 2 times 20 is 40, okay? So this is the same thing as 0.4 or 40%, okay? That's why simplifying fractions is so very important. The smaller the numbers, the easier it is for your mind, your brain to make sense out of this ratio, okay? All right, number 2, a game contains 10 cards numbered 1 through 10. What is the probability of drawing an odd number card? What is the probability of drawing a number greater than 4? Okay, 10 cards numbered 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10 cards. The probability of drawing an odd card, we got 1, 3, 5, 7, 9, right? So that's going to be probability of odd. That is going to be equal to come on, you can do it. Sorry, trying to do this stuff. Come on, this camera adjust. Okay, I'll keep going. Maybe I'll focus here in a second. Hopefully that's good enough. All right, the probability of drawing an odd is going to be 5 out of 10, which is equal to 1/2, or 50%, or 0.5. Okay, all those are good. Now, then it says, what is the probability of drawing a number greater than 4? Probability of number greater than 4. Okay, how many numbers do I have greater than 4? I have, count on your fingers if you need to, 5, 6, 7, 8, 9, 10. Okay, that's 6 out of 10, which equals 3/5. And guys, I'm not going to care how, unless it says in the directions how you leave your probability. I'm not going to care. I'm not going to care which form you leave it in. I would just say use common sense. I mean, if we're talking about the probability of drawing a card out of a deck, 3 out of 5, that makes sense. If we're talking about the probability of it raining tomorrow, I'm not going to say 6 out of 10 times. I'm going to say there's a 60% chance of rain, right? So you just use whatever form makes sense for that particular problem, okay? All right, number 3, what is the theoretical probability? This is a funny one. What is the theoretical probability that tomorrow is a school day? Now, once again, in April 2020, unfortunately, we are all still quarantined and we are having to stay at home. So I guess in this case, the chances of us going into a classroom tomorrow is going to be 0%. But under normal circumstances, the theoretical probability that tomorrow is a school day. We've got 5 school days out of 7 days. Oops, sorry. Probability that tomorrow is school is 5 days out of 7 days. This is really bothering me that this won't focus. Hey, there we go. That's more better. Okay, let's keep going. Number 4 here, Marcus tosses a coin 20 times. The chart below shows his results. What is the experimental? Okay, so when we're dealing with experimental, guys, we need a chart. We need some data that says what actually happened when I ran this experiment. What is experimental probability of landing on heads? Okay, all right, so probability of a coin landing on heads based on the experimental data, and landed on heads 13 out of a total of 20. Okay, so 20 times 5, what do I have to multiply 20 by to get to 105? 13 times 5 is 50, that's 65%. 65% chance landing on heads based on this data and those results. Okay, this last part is incredibly easy. So I'll go through this pretty quickly. Tree diagrams, fundamental counting principle. It says Tucker has 3 choices of sandwiches: peanut butter and jelly, ham or turkey, 2 choices of fruit, banana or apple, 2 choices of drink, water or juice. Make a tree diagram to illustrate all the possible outcomes. You guys have been doing this for a while. You guys probably did this back in middle school. Okay, so we got 3 choices of sandwiches. We've got P, B, and J. My son loves peanut butter and jelly. He loves peanut butter and honey too. We've got ham, and we've got turkey. So those are our 3 choices, and then from there we can start drawing our tree diagram. Okay, from each one I have a choice of fruit, banana or apple. I'm just going to abbreviate here, B and A, B and A. Okay, and then after that, stemming from those, we can have 2 choices of drink. We can have water or juice. So stemming from here, water, juice, water, juice. Okay, so those are all of our different possibilities. It says make a tree diagram to illustrate the possible outcomes. How do I figure that out? You just go to the bottom of the tree. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different possibilities. I can do peanut butter and jelly, banana and water, peanut butter and jelly, banana and juice, ham, apple, and water. Obviously, you got lots of different combinations. So if you count all those up, you get 12. Is there an easier way to have gotten 12? Well, there were 3 choices of sandwiches, 2 choices of fruit, and 2 choices of drink. 3 times 2 is 6 times 2 is 12. And that takes us to our fundamental counting principle that says if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. Okay, this principle can be extended to 3 or more different possibilities or combinations or events. All right, number 1. At a sports goods store, skateboards are available in 8 different deck designs. Each deck is available with 4 different wheel assemblies. How many skateboard choices does the store offer? No need to draw a tree diagram. I simply multiply 8 times 4. 8 times 4. Let me get my calculator. Can't do that in my head. 8 times 4. Ah, yes, it's 32. Please laugh at that. Please laugh at that. Okay. All right. So next one, example number 2. You would like to go to a movie, a play, or a zoo. You can go with your cousin, your brother, or your friend. 3 possibilities there. You can go on a Friday, Saturday, or Sunday. 3 possibilities there. How many different options? Oh, I'm sorry. You would like to go to a movie, play, or a zoo. 3 options there. 3 options for the people and 3 options for the day. So that's simply 3 times 3 times 3, which is 3 cubed, which is 27 different options or possibilities. And last but not least, again, pause the video if you want to do this on your own real quick. Trevor is going to a business interview next week and has 48 different clothing options. He has 4 ties, 4 shirts. How many pairs of slacks does he have to choose from? Now here we're working backwards. They tell us that we have 48 different options. So normally we do something times something times something equals 48. Well, we've got 4 ties times 4 shirts times the number of slacks. That's what we don't know. So that when in math we don't know something, we put a variable there. And that equals 48 different options. So we're working backwards. So we got 16x equals 48. X is equal to 3 pairs of slacks. All right, that's it, guys, for probability lesson day number 1. Please work on your homework at some point today. Again, I will be taking all of this up in your packet. Please do not follow behind. You need to be doing this every single day. Go ahead and staple your packet. Keep all that stuff together so you don't lose it. Hope you enjoyed this video, and we will see you on the next one.